For an object moving in one dimension, its instantaneous acceleration can be found by looking at a graph of its velocity versus time, and at some particular instant, we draw a tangent line to that graph, and the slope of that tangent line is delta v over delta t. The slope represents our acceleration at that one instant. So now in two dimensions, the instantaneous acceleration is still the rate of change of the velocity, but velocity is a vector, so our instantaneous acceleration also now a vector. It has components ax, the instantaneous rate of change of vx, and ay, the instantaneous rate of change of vy. Let's look at an example. Here is a map of an object's path through space. Starts here and is moving off in this direction. Now I've drawn in its velocity vector, which is of course always tangent to the path, at three different moments. Let's label this middle moment t0. So we see that the speed is remaining more or less constant along this path. The magnitude of the velocity is not changing, but its direction is changing. The consequence of that is that the x component of the velocity starts out small, but then increases and increases some more. The x component of v is increasing the whole time. The y component, however, starts out large and then is smaller and smaller. So the y component is positive but decreasing the whole time. If we were to graph those two quantities versus time, we would see this. The x component of the velocity versus time, we see that it starts out small and then increases. Starts small and is increasing the whole time. So that at a particular moment, t0, right here, we could draw in the tangent line to that graph, take its slope, and then that would represent the instantaneous x acceleration, the x component of the instantaneous acceleration. On our vy versus time graph, we saw here that our velocity in our y component of the velocity was positive but getting smaller this whole time. So here we see the y component of velocity being positive but decreasing as time goes on. So at this particular moment, t0, we draw in the tangent line and measure its slope, and that delta vy over delta t represents the y component of the instantaneous acceleration. We'll see an application of this in projectiles.